In this next section, we're going to focus on the cognitive development side of infancy and childhood development. So this section is going to be a lot of Piaget as one of the most well-known child psychologists who looked specifically at cognitive development. So that's going to be a big chunk of this section here. So Piaget was a Swiss psychologist, and he worked in the field for over 50 years, focusing mainly on observational studies, just to see how children learned and what processes they seemed to follow. Taking all of the information that he got from all of his observational studies, Piaget decided that the brain builds schemas to achieve understanding. If you recall, schemas are a concept or a framework, basically like a mental rule that help us make sense of things. So Piaget was saying that we're going to build these schemas, these mental rules, to help us understand the world that we're interacting with. And our schemas are going to be modified to try and create equilibrium or balance between our environment and our understanding. So as we encounter new things, we're going to adjust our schemas. And this process of adjustment is going to involve two basic categories of adjustment. The first is the idea of assimilation. So with assimilation, new experiences are incorporated into existing schemas. An example of assimilation would be when a child who has never seen a horse before sees a horse for the first time and decides to call it a dog. So it has 4 legs and sort of a big-ish head. Yeah, that must just be a large dog. So that child has assimilated that concept. So they've brought horses into their pre-existing schema, their set of rules that helps them define what a dog is. The other process that we might see is called accommodation. And with accommodation, new experiences that we have cause our existing schemas to change. Now, this process of accommodation can also cause the development of new schemas. So you might find that the concept of dog doesn't really apply to a horse. So maybe now your concept of dog changes because horse-like things don't fit into it anymore. But now you develop a new schema that helps you figure out what horses are. So you're going to adjust existing schemas and create new ones to try and better fit the information that you encounter in your environment. In Piaget's stage theory, he argued that our cognitive development is going to pass through 4 distinctive stages. These 4 on the screen here: sensory motor, preoperational, concrete operational, and formal operational stages. And he figured that everyone would pass through these stages in the same order. Each of these stages was meant to signify a large growth or a large leap forward in our cognitive growth. So we're going to talk about each of these 4 stages one at a time, as well as some of the things that children would do that shows that they have achieved each of these stages. So let's start with our sensory motor stage. And this goes from when you're born all the way up to 2 years of age. Now this stage basically states that you understand the world primarily through only 2 systems: your sensory system and your motor system. So your sensory experiences, the things that you can feel and hear and touch and taste, and your physical interactions with objects, things that your motor system allows you to interact with. Early on, we start off using our reflexes, things that happen naturally, but over time we can learn and begin to acquire new skills. As they progress through this stage, children start to learn that they can cause things to happen. They can interact with their environment and create reactions. And then towards the end of the stage, children begin to acquire language. And as they start learning language, they start applying more symbolic concepts. And that marks the transition into the next stage. But one of the key concepts that gets linked in with this sensory motor stage is the idea of object permanence. And object permanence is simply the understanding that objects are going to continue to exist even if you can't see them. Now, before the age of about 8 months, when something is no longer within their sight, that thing no longer exists to that child. So if we look at this image on the side here, when their toy monkey is covered up by a piece of paper, the child doesn't bother to look for it. They don't display that behavior of seeking the toy, because as soon as they can't see it, the toy no longer exists. Now, you might have experienced this if you've ever played peekaboo with a child or tried to play hide and seek with a very young child, where sometimes they don't realize what's going on. And that's because when they can't see you, they don't realize that you exist. And then that changes at about 8 months, where once a child is about 8 months old, as soon as you cover up the toy, instead of looking away and losing interest, the child will start looking for that toy. They might try and look behind the piece of paper to be able to see it. So that's sort of one of the things that happens during this stage. Our second stage is this pre-operational stage. And this covers age 2 through to 7. So it follows right after our sensory motor stage. And this is when children start representing things in the world symbolically. So they start using words and mental images to represent the things that they encounter. Despite starting to have this ability to symbolically represent things, children actually lack quite a few of the sort of standard mental operations or rules that we think of as essential to exist. So they're going to run into a couple of problems. We'll talk about something called conservation, where they have difficulty understanding that concepts hold constant over time. There are also some errors where their thinking displays irreversibility, where they find it very difficult to reverse an action mentally, where they can't really think about it from the other side. Centration, where they focus or center on one particular aspect of a problem and exclude other aspects. They'll also show animism, which is basically the idea that plants, animals, and inanimate objects all have sort of some kind of personality and human-like quality. So they'll look at, say, a stuffed animal and think that it is a real person that they can talk to and interact with. And the last concept here is egocentrism, where they focus on themselves and don't realize that others can have a different perspective. Now, we're going to touch on a couple of these in context in just a few minutes on the next slides. So what all of this is telling us is that even though children are starting to learn more words, they're starting to have grasps of different concepts, and even starting to learn much more symbolic and abstract concepts, even things like times and places that are removed from now. So they can talk about the past and the future, that displacement quality of language. And they can even start anticipating consequences of their actions when they're in this stage. They still have some downsides where their logic and understanding of rules is just a little bit lacking. But, young children, that's how they are. Now let's focus just a little bit on a couple of the ideas that we talked about in terms of conservation and egocentrism and some of those concepts, because these are really key parts of this pre-operational stage, especially as Piaget focuses on them. So the first idea is conservation of volume. And you can look at conservation of number or conservation of mass, but we're going to start with conservation of volume. But basically, a child who's in the pre-operational stage doesn't understand this conservation of certain traits. So if we look at this setup right here, we have two shorter, wider glasses and one tall, skinny glass. So we can look at this and we can see that these two glasses have the same amount of water. So we have this initial equality. And you can show the child then that you would take the water from this glass and pour it into the taller, skinnier glass. And then you would ask them, which glass has the larger volume of water? Which one has more water? So this process of moving the water from one glass to the other is called transformation. And then you can ask them which one has more. And this is where we start to see that sort of different logic. Because you and I look at this and we watched them pour the juice from, or I'm saying juice now because they said juice here, but it looks like water. So they poured the water from one glass into another glass. The volume of water hasn't changed. The volume is conserved. It's kept the same. So neither glass has more than the other. We just watched that happen. But to this pre-operational child, they're going to think that one glass obviously has more than the other. In this case, most children will say that the taller glass, the one that has the higher line, they're going to say that that one has more water in it. So they will focus or center on that volume there, that height, and assume that that larger height means larger volume, so they are confident that this one will have more water in it. So that ties us back to that idea of centration, where they are focusing or centering on that one aspect of this particular scenario. So they focus in on the height of the line, assuming it's going to tell them about volume. Towards the end of this preoperational stage, they're going to be able to understand that the volume of water was conserved even though it was moved between containers, and the height doesn't really matter as it relates to volume. We can also apply this same idea to conservation of number. So you can look at these two lines. So maybe you have a bunch of M&Ms and you can show them 2 rows of 5 M&Ms each. And at the beginning, they are the same, but if you spread out the bottom row and ask them which row has more M&Ms in it, they're going to almost always select the one that's more spread out, because they assume that a longer row will have more M&Ms to it. So they don't understand that conservation of number. And you can probably see where this is going with conservation of mass, where you can start with 2 balls of clay, where they're the same size, and then if you squish one so that it takes up a larger surface area, the children will assume that the squished one is now larger because it's taking up more surface area. So all of these are sort of failures in logical understanding of rules because they don't have a grasp of conservation yet. For our next term that we can talk about for this preoperational stage, we're going to look at egocentrism. And as I said on the slide previous, egocentrism is simply difficulty viewing the world from someone else's perspective. So not being aware that other people can know things that are different than you. Usually when you see the word egocentrism, some people will assume that it means that you are self-centered, meaning that you are selfish or self-absorbed. But in this case, you're actually self-centered in that you're only aware of your own awarenesses, if that makes sense. We'll try and clear it up with an example here. So they use what's called the 3-mountain question or the 3-mountain problem. And they'll have 2 children sit around this table. So one will be sitting behind the table, sort of behind this big mountain, and one will sit in front of the table, in front of the mountains, and they'll look at the map. And the one sitting here in front of everything will be asked, what does the person back there see? They might ask, do they see this road? And the child in the front, if they are of the pre-operational stage, they won't have a concept that the person behind the table's view is going to be blocked by the large mountain. So the child sitting in front assumes that the child sitting behind sees everything that they can see. Another example that I've seen of this is you'll have a child sit in a room and they have a friend with them. So their friend will sit with them and they'll watch the researcher hide a ball. So they'll put a ball in a basket and then the friend goes to the bathroom. So they're out of the room. The researcher will then come in and remove the ball, and then the friend comes back from the bathroom. And if the child who didn't leave is asked where the ball is, or where their friend thinks the ball is, the child assumes that their friend knows that the ball is elsewhere, that the ball was removed, simply because the child saw them remove the ball. They don't have a concept that because the friend was out of the room, they didn't see the same information. So egocentrism basically leads children to make assumptions that everybody knows exactly the same information that they know, and that there's no difference in what everyone is aware of. Our third stage is the concrete operational stage. So this one's going to go from age 7, the end of our pre-operational stage, all the way up to age 12. Once they reach this stage, they should be able to perform some basic mental operations as long as they involve tangible problems and situations. And what I mean by tangible is something that is sort of concrete, something that they can sort of clearly relate to or see. At this stage, they will have finally grasped that idea of conservation. They'll start displaying less of that centration. They're also going to be starting to display some idea of reversibility, where they can think about things from different angles and think about it from one side or the other. But the children are still going to have difficulty with problems that require abstract reasoning. To illustrate this difference between sort of tangible and concrete problems versus abstract reasoning, we can look at the standard idea of if you asked a child to draw somebody with a third eye. So you give the child a picture or let them draw a picture and say, where would a third eye go? Children who are in this concrete operational stage, they can do it, they can draw in a third eye, but they're usually going to follow some sort of concrete, tangible, and relatable solution. So if they draw a face, they'd probably draw the third eye in between our normal two eyes. And their reasoning would be more concrete because they'd say, well, eyes go on the face, so I put this eye with the other eyes. Whereas as you move out of this concrete operational stage, you can start thinking a little bit more abstract. So maybe you would put a third eye on the back of your head so that you could see from a different angle. Or maybe you'd want an eye on your hand so that you could see things when you reach, or something like that. So when you start having those more abstract grasps of concepts, that's as you're leaving this concrete operational stage. But most children, when they start in this stage and when they're in the middle of this stage, are going to have issues moving away from sort of physical, tangible concepts. They don't think as abstractly. And then our last stage is the formal operational stage. And this is going to start around age 11 or 12 as they finish all the other stages. And this is going to be where you sit for the rest of your life. And so once you hit this formal operational stage, you can start thinking logically about both concrete and abstract problems. So that's when you would start to think about where would it be useful to have a third eye in this theoretical place. Children are able to start forming and testing hypotheses. So these grasps of more abstract concepts allows them to start thinking about what would happen or why things might happen. And they start asking questions that go along with that. And then this is where they're going to stay throughout development after they've reached this stage. So this would be what we fall under. Now, if we're talking about Piaget's stages and how important they are for cognitive development and for our understanding of that development, maybe we should take a moment and think critically about this proposal. How much support does his theory have? So first off, there have been many attempts to try and replicate these sorts of observations in multiple cultures and different places around the world. And luckily, we've actually found that a lot of the cognitive abilities that are identified as key for each of those 4 stages seem to develop in the same order across multiple cultures in different countries around the world. So this gives us some evidence of a universality principle, where these sort of stages and this order of development seem to be consistent across all people because we're seeing consistency between different cultures. On the other side of things, we run into some evidence that children are actually acquiring some of these cognitive skills at earlier ages than what Piaget originally believed. And some of this seems to actually be a fault of methodology. So when I started talking about the idea of object permanence, I said that children would start to look for an object that's covered up. Well, to sort of make note of that looking behavior, you'd have to be able to observe the child moving and looking and perhaps peeking around the piece of paper or relocating that piece of paper. However, there's sort of a confound here with motor development. At younger ages, before that 8 months of age cutoff, children don't have a lot of control over their arms and their hands and that grasping motion. So they couldn't necessarily look in a way that would actually allow us to register that they're looking. So if you designed the experiment a little bit differently, if you made it so that children don't have to physically move around in order to show that they're looking for an object that's now removed from sight, we actually end up finding that they show this idea of object permanence quite a bit earlier, sometimes as early as 4 months old instead of the 8 months that Piaget originally proposed. Now I want to hop ahead to an alternate arrangement, an alternate setup that could help us show this idea of object permanence in a way that doesn't require the child to be able to physically search for a missing object. So when we talked about infant development very early on, we had mentioned the idea of measuring looking time. So how long an infant stares at something to show their amount of interest in it. So we can use that same principle here to test young infants to see what they are expecting. The idea being that something that happens as expected is going to be less exciting and therefore less interesting than something that is unexpected or even impossible. So I'll get at what I mean right here by explaining this setup right now. So what this drawing here is showing us is an infant sitting and seeing a screen that swings forward. So the screen starts in front of them, it can flip up and over and settle down on the table behind. So we can habituate them to this setup. We can get them used to this occurring so that they know that what this screen does is it gets swung up and over and lays flat on the other side. And once they've habituated to that, they no longer respond to the screen moving because it's no longer exciting. They've seen it happen multiple times. They know what's going to happen. So the next stage is that the researcher can go and place a box, this purple rectangle, in the place behind where the screen falls over. So to this infant, if they understand that the box is an object that exists, and if they understand that that object will exist even when they can't see it, When this screen then moves up and over, it should encounter that box and stop moving. So that would be a possible event, something that the infant could theoretically expect if they understand object permanence and understand that that box exists and can stop the screen. What's at the bottom here is an impossible event. The idea that the researcher could place the box behind the screen, and then the screen could still continue to fall and land flat on the other side, even though the box was in the way. Now, as the researcher, you can show the child that you're clearly putting this box behind or stand it up on the screen here so that when you start moving this screen, it'll stop. But you could also, in this case, when the screen is standing upright and fully blocking their view, you could remove this block so that when this falls forward, instead of getting stuck on the box like they expect, it would continue to fall and land flat on the other side. So you have a possible and expected event and an impossible and surprising event. And what they find is that at as early as 3 or 4 months of age, children will stare longer at this surprising and impossible event because we're assuming or inferring that they have this idea that this shouldn't happen because the block should be blocking that screen from flipping. So we've set this up in such a way that we can see what they're expecting, what they sort of understand of the world, and we gauge their reactions accordingly. And it's really cool to note that in this case, the child doesn't have to sort of move around and look for that object. All we're measuring is whether or not they're looking at this event and how long they look at the event for, which is really, really cool because they can't tell us what's going on, but we can infer it from their reactions. I'm going to hop back to this page so that we can continue on with other critical thinkings in terms of Piaget's stage theory. Our next point here is another negative for this stage theory, and this is the fact that development within each stage proceeds inconsistently. And what this basically means is that some children might be performing at the stage of, or at the level of, here so I can see them all. Maybe they're at the level of concrete operational when it comes to things like math problems. But maybe they're also struggling about something pre-operational. Maybe they're having issues with egocentrism. Or maybe they still haven't quite grasped that idea of conservation. So children can have qualities that fit them into multiple stages at different ages. So even though these are presented as sort of discrete boxes that children will fit into, we end up finding that there's a lot more crossover and inconsistency in where children fall than the theory would have us believe. And then our last point is this idea that culture influences cognitive development. From our conversation through all of these key defining points that tell us which stage children are in, you might have picked up on the fact that a lot of these deciding features, a lot of these cutoffs revolve around the development of logic. And logical reasoning is a hallmark of very Western cultures. So this focus on the ability to logically figure out a certain thing or logically work your way through a problem is very important in Western cultures, but is a lot less emphasized in other cultures. We've already kind of touched on this idea that your culture, the things that you are exposed to, can shape how you view the world around you. So it makes sense to start looking at other cultures and other cultural influences because those are really going to dramatically affect your cognitive development. It shouldn't just be reliant on logic and more Western-focused ideas, especially if we're trying to come up with a cognitive theory that applies to all humans, not just people who are born in Western countries. Our big take-home from all of these is that cognition is going to be a lot more complex and variable than what Piaget originally proposed. There's a little bit more going on here than is entirely encapsulated by his stage theory. So there's a little bit more to it than just those 4 stages. And we should keep that in mind as we move through this chapter. That. I also had included another example in case this screen and box situation hadn't quite shown or hadn't quite sunk in for how we can also test for object permanence. This is another, a little bit more complex setup where you can look at children's reaction to an expected or unexpected event. Basically, you could set up a puppet theater. You can have 2 objects placed on the stage, and then a screen comes up to block those 2 objects from view. You can have an empty hand enter, so basically somebody reaches in and removes one of the objects from behind the screen. So the child watches. If they have an idea of object permanence, they should understand that there were 2 things behind the screen, and now that the hand has removed an object, there should only be 1 left. So we have this possible outcome where the screen would drop and reveal a single object, or an impossible and surprising outcome where the screen drops and reveals 2 objects, even though 1 had just been removed. And so the same as with the screen problem, where the children will stare for longer at these impossible or surprising outcomes, that's the same observation that you make here, where if the child stares longer at this impossible outcome than they do at the expected possible outcome, then you would conclude that they have some concept of object permanence if they would know to expect this outcome, but not to expect this. Now, for the next little bit, we're going to talk about people other than Piaget. But a lot of them are going to have built on Piaget's original ideas. So Piaget had acknowledged that social interaction is important in our cognitive development. He was aware that the things that we would interact with would help influence our development. But he chose to focus all of his observations and then his theories, or his theory based on those observations. He chose to focus on children and what they did when left to explore on their own. So he would have, say, researchers present a situation to the child and then see if the child could solve the problem, or ask the child how a certain scenario should play out, or ask them a certain idea or something like that. So it was a lot of exposing children to a concept and seeing how they reacted naturally. Vygotsky, a name that I constantly have to look up the pronunciation of, was a Russian researcher who decided that he wanted to focus more on this social interaction and ended up proposing the idea of a zone of proximal development. Basically, he focused on the idea that even though children who are faced with this new scenario, like in Piaget's experiments, where you show them glasses and ask them which one has more volume, even though 2 children might have the same response, they might automatically assume that the taller glass has more liquid in it. Vygotsky wanted to ask, well, how do these children differ in their learning ability? How do they differ in what they can do with assistance? So what if you have 2 children, Jane and John, and let's say that Jane and John are both shown the glasses conservation of volume scenario, and both of them fail to understand that volume is conserved. But Jane goes home, talks to her parents about it, and they start experimenting. Maybe they play around with different sized glasses in the kitchen, and they teach her about the concept of volume and specifically conservation of volume. If John is also given the same chance to play around with different volumes and containers, but he still doesn't grasp the idea, but Jane, with help, does grasp the idea. Piaget would say that they were both still at the same cognitive stage, but Vygotsky would say that Jane was at a different stage because that training, that assistance, helped advance her cognitive ability. And that's what the zone of proximal development focuses on. It's that difference between what a child can do independently and what they can do with assistance. So this is going to help give us an idea of what's going on with cognitive abilities that are in the process of developing, the ones that are in progress, that are actively maturing. So the ones that can be influenced by just a little bit of external help. And so there's this idea that other individuals or other scenarios can help facilitate this development as long as the child is capable of making use of that assistance. So we still have those biological limits of what children are cognitively capable of, but we can kind of push those limits with our environmental factors, with our environmental influences. So keeping in line with all of the theories that we've talked about so far, with the environment and the biology kind of working together. So we've discussed how Piaget focused on his stages of cognitive development. We talked about Vygotsky talking about his social context for social development and how that could work together. The next couple of slides we're going to talk about are going to delve into our information processing approaches. Basically, researchers who would look at how young children learn things, how they're viewing the world, and how they're processing information. So we can look at the image on the screen here, where researcher Verpilot, all of the names to pronounce today, goodness. But this researcher would show children these two images, and they could ask them, are the two images the same? And they would compare performance between older children who could look at this and very quickly tell you that no, the two houses aren't the same, and how that compared to younger children who would end up telling him or them that the two images are the same. And so in this experiment, they would actually film eye movement to see how the children of different ages are actually processing this information. And they found that older children would systematically scan this image. So they would look at this and compare to this. They'd look at this window and compare to that window, this window to that window, and so on and so forth. So there's this systematic scan that allows the older children to quickly decide that no, these two images aren't the same. But younger children in preschool would fail to scan systematically, and they would then claim that the houses were identical because in their eyes they seemed to be. Psychologists that follow this information processing approach would focus a lot more on the idea that our development is gradual and continual, as opposed to following those set stages as outlined in Piaget's original theories. So as our physical capabilities evolve and grow and change, so too would our mental capacity grow as well. So over time, our information search strategies are going to improve. We're going to learn that certain ways of looking at stuff is going to be more efficient, and we can start using those more efficient patterns more often. And our speed when we're using these information processing pathways is going to get faster. We're going to start thinking more quickly. Our memory capabilities are going to improve. Basically, we're going to have a stronger memory. Our working and short-term memory is going to develop to the point where we can start holding multiple ideas in our minds at once. And all of these extra capabilities, all of these extra abilities allow us to start developing this idea of metacognition. We can start thinking about the fact that we are capable of thinking. And so this leads us to a very, very interesting topic that I wish we had way more time to talk about. But this is the idea of a theory of mind. And a theory of mind refers to a person's beliefs about the mind and ability to understand other people's mental state, which is basically a fancy way of saying that we can think about the fact that other people can think about things differently than we can. Of course, metacognition stuff gets quite meta quite quickly, but as you develop, you start to have the idea that other people know things, that they're going to have different information than you do. They can also think about things differently because their brains aren't the same as ours. And so as children grow and mature and develop, they start to realize that not everyone knows the exact same information that they do. So we can talk about that original example of egocentrism, where children couldn't grasp the idea that another child didn't know the exact same information that they did. They couldn't conceptualize, they couldn't form a theory about the fact that their friend hadn't seen the exact same scene that they had. And so some evidence for when children start to develop this theory of mind is when you start seeing them put themselves in others' shoes. Okay, well, what can that person see? What are they thinking? We also start seeing this being employed when children start to lie or use deception, because as soon as they have this understanding that not everyone knows what they know, all of a sudden it starts to make sense that they can withhold information, that they can give false information because the other person doesn't necessarily know different. And so this progression, this brief understanding of a theory of mind, slowly starts developing around the age of 3 or 4. So that's when you start to see children will start lying, when they start understanding that other people have different perceptions than they do. And that grasp of that theory of mind will grow and develop as they get older.